Hey all, Brad here with another video. On the bench today, I've got a Joust board set. Customer of mine, Joel, sent in. He sent in the board set along with the linear power supply and heatsink. So we went through and did all the repairs, upgrades. Some of the boards got the simple green bath and cleaned up. Um, Also, he had the older yellow version of game code on it, and the labels were a mess. And those yellow labels, most of them are the A ROMs, which are 2532s, and the later Joust games, the majority of them use the B ROMs, which are the 2732s. So I swapped those out, got new labels on them, and we also did a pause mode um, on mod on one of the ROMs here, so it enables the pause mode. So I'm going to go through everything, show you what I did to the boards, and then we'll do some gameplay and get this video wrapped up. So let me switch over to my bench cam, and we'll get up. I'll start with the linear power supply back here. So here's the power supply fully restored. This one, someone had done quite a bit of work on this over the years. They had some new caps and some different components and pieced together some Molex headers with square pins, but I stripped it down to bare bones, simple green bath that did some repairs on a few things. And then once it was clean, it got all new Molex headers. These are the correct ones with the ramps in them, the friction lock headers. We've got the green LEDs, kind of my trademark thing I've been doing. It's got all new electrolytic caps on it. Put a 10-turn precision potentiometer for the 5-volt adjust. Got some new sockets for the voltage regulators here. This one's for the 12 volts and 5 volts. All the bridge rectifiers are new. Under here's the big BR1 5-volt bridge rectifier with a custom heatsink I put on. We've got a 12-volt bridge rectifier here, and then back here is the minus 5 volts. Actually, I've got my little fancy finger pointer thing I picked up, which I kind of like here. There's a little hand. And then there was also a high watt resistor here. This is used for dropping the voltage down for the coin door lamps. It's very low. It's zero point 0.2 ohms, so that's or this one is 0.52, I think, like a half ohm or less. Anyway, so that's new. That's a 5 watter on there. Pulled all the fuses out. Um, Recrimped all the little legs here so they go and they snap in real tight. Some of them are loose over the years just from hot and cold and friction. I clean up the ends of them real good with some Scotch-Brite pad, and then I verified that the values are correct in the right location. You'd be surprised how many times I get 20 amp fuses in where a 4 amp's supposed to be, things like that. So all new caps. Back here on the heatsink, I pulled both of the power transistors. This one in the front is for the 5 volts. Um, this is a 2-in 6057, and the one in the back is a 2-in 3055 for the 12 volts. Pulled those, put new sill pads underneath them, cleaned them up, clean up the harness, and then I do replace the Molex header here, and I put in the Trifurcon pins and a polarizing key that prevents you from plugging it in wrong or whatever. So that's solid. And then up here on the plate, I've got the customer soundboard that I went through. Again, it's got all new electrolytic caps on it, new bridge rectifier. I put new heatsink compound under the 7805 voltage regulator, as well as the TDA 2002 audio amplifier. I do the same thing with the fuses, recrimp those, clean them with Scotch-Brite, snap them in, they're real tight. All new Molex headers up here. What else did this board get? I think actually there was a bad crystal on it. So it got a new crystal oscillator, a low profile one, and then a couple new capacitors. The original capacitors that make up that oscillation circuit, they kind of stand proud on the board, kind of like one of these ones here. So I put just the axial leaded 22 picofarad in for that. So the clock is real solid on here now and running real well. I think that was the customer had a problem with it. Also on this, he sent the original volume pod. No major issue here. I did clean it up a little bit, cleaned up the cabling, and then I did put a new connector on the end. The other one didn't have a polarizing key, and it was pretty dirty and stained, so I put a new one on there. Then we've got all of the customer's old parts here. I return those unless somebody says don't return them. But I tend to do that. So all the capacitors and old battery holders and ribbon cables and a lot of stuff in there on these boards we swapped out. Coming back here on the ROM board, again, I mentioned in the video, this has the green version, the latest version of the ROMs, and these are 27C32s. So these are CMOS variants. They draw a lot less current and therefore run cooler, and they're actually a little faster than the 2732s that are bipolar. And then to switch from the 2532s, there's a jumper here you have to move and one over here. that gets moved. And then we've got new Nichicon filter caps on the power, square pin headers that are new here, all three positions. I pulled the blitters out and cleaned them. I've got reproduction labels on those as well for the special chips. We've got a new 3M ribbon cable on here with a new connector that I make up myself. So the ROM board's rock solid. And also ROM 10 here is the one that has the custom code for the pause mode that I burn in there. So, and then here's the I/O board, two new 10-pin Molex headers, new electrolytic cap, uh, new ribbon cable. Again, I make these ones up as well. This was cleaned up. No smoking gun here. Everything was pretty good once it got cleaned up. MPU, this is a Rev D MPU. This had the inductors over here that stood vertically, and they bend and they break. And so I pull those and I put in these real nice horizontal. They're much more rigid. They're the same value. They're 2.2 microhenries. Um, for these were put in for EMC, electromotive compatibility. The FCC, the Federal Communications Commission, back in the 80s, they had problems with these boards emitting a lot of radio signals and interfering with pacemakers or people's wireless devices. So they started to crack down, and Williams responded, and this was kind of their fix. They put some inductors in here, which really cuts down on that. So new filter caps here, all Nichicons, -5. 12 volt and +5, and then a new 22 microfarad tantalum capacitor, axial leaded for the soft start. What this does is the relationship between this capacitor and a resistor, it takes so much time for this to charge because you're limiting the current. And what that does is when you first apply power, it keeps the board in reset mode. So nothing's running in here. There's no compute going on, if you will, until that thing gets to full charge, and then it trips a couple transistors and it lets it come up. So they call it a soft start or a supervisory circuit that does that. Sorry about my phone blowing up here. And I also put back here this diode right back here. This is ZR2. This is a Zener diode that monitors the 5 volts coming in. And Williams used a 3.9 volt Zener. So what happens is this, if the voltage can go all the way down to 3.9, and this board will stay running. And anything really below 4.7 volts for TTL does not make it happy. So running a linear supply, there's some protection against that because we're actually tripping on the 12 volt. But if you run a switching power supply, switch mode, then you run into problems where you get a corrupted CMOS RAM. So I put that on all the boards I do. I put in a 4.7 volt. So anytime the voltage gets to below 4.7, it pulls the CPU into reset. Put new labels on the video decoders, pulled them, straightened the legs, cleaned them. Same thing with the CPU. Cleaned the whole board up. Pulled the old battery holder. Had quite a bit of corrosion on the bottom on a couple of the old AA's here had leaked out their alkali. So we got a nice CR2450 on here. This thing will probably last 10 years on this board, 7 to 10 years, I would say. So everything's rock solid. Let me go ahead and switch over and we'll do a little gameplay. The other thing I did on this, I'll show you when we get to the track screen, is Lonnie McDonald, who's known as the Joust master. He traveled around the country for a few years playing people's Joust in arcades and in their home arcades. And he usually initialed the marquee and wrote the number that he played and all that. And what he did is he flipped it over for like 1,000. So let me go ahead and power this down. I had it up so you could see the green LEDs, but I will power it on here. We'll go through the normal rug pattern, carpet pattern. This is really just test the board, doing a self-test on the RAM. All systems go, and you can see it goes right into a track. And if you look on the screen there, it says LAN 999999, and that's his high score. So somebody had sent a board in a number of years ago that had that. They were really concerned. They wanted to make sure they were able to keep that. I didn't delete it. So I've got a tool that I use, FPGA Catbox, where I'm able to plug into the CPU, and I can read out the contents of the CMOS RAM and store it as a file on the computer. And I'm also able to restore that. So I backed up a Joust board that had that LAN high score in there and kept it. And then I reached out to LAN and said, hey, would you mind if I installed this on other people's board? And he was, happy to let that happen. Typically when I get a Joust, if this one had no batteries in it, so there's no contents in the CMOS. So I put that in there. People like it, they can leave it. If not, it's easy enough to just go. I'll show you when you go into the settings menu, you can just reset the high score table and reset that back. But so the game's booted up fine. I'll go ahead and just do a little gameplay here. It's set to free play, so I'm just gonna hit start here. Again, I will put a disclaimer that I'm much better at fixing boards than I am at playing them. Oh boy. We'll drop into the diagnostics here. It's playing fine. This board, I will mention that it did run probably 48 hours with the complete board set here, but it ran independently after I did the soundboard or the power supply. I did load test it on my dual channel DC load tester for about 8 hours, the power supply, and then I did the soundboard, and then the ROM and IO ran on the bench with one of my MPUs, and then I did the MPU last, and then it ran as a system for at least 48 hours. So no RAM errors, no CMOS errors. Sound, we can loop through these. And then back to 1. Well, the reason it does 6, it's able to test all the digital outputs that come from the ROM board to drive the soundboard. So really, if you've had a combination of sounds that exercise each one of those digital outputs, then you know that they should all work at that point. So here's the switch test. So left, right, we've got flap. I think I had player 1 start, coin up, and I did run this I/O board with a splat board where I test all 18 inputs. These I/O boards are used for Joust, Robotron, Bubbles uses this I/O board, Stargate uses this, and Splat uses it. And Splat is the only one of the games that uses all 18 of the potential inputs. So I usually put that on, and I wrote a little routine where I can just hit on my little PlayStation controller here. I hit the X button, and it'll go through and sequentially exercise each one of them. And then when I'm done, I count them to make sure there's 18. So I do that on every board because some guys have, like with arcades, they maybe switch boards from one game to another when they're troubleshooting, or if their favorite game goes down, they might rob a board from a different Williams game. So I want to make sure that all of the inputs work on these boards when I do them. So. And then color RAM test. So here you have 3 intensities of red. You'll see it auto sequence through the 3 intensities, and then it'll go to green with 3 intensities, and then blue will have 2 intensities. And then it'll just loop through that. So then we come up to the grid lines here. This is where you would set your convergence on your monitor. Get everything adjusted in for all 3 of your guns, red, green, and blue. And then make the little white dots if they're all converged properly. And then you can also look at linearity and things like that with these lines. And then we have a solid red, solid green, solid blue, color bars after this. And then this is our bookkeeping data. And again, on these Williams games, it's kind of slick. When they have the coin door, and then below it is what they call the coin vault, and they can be keyed differently, or they were back in the day. And maybe you had the 16-year-old kid working in the arcade, and he had a key for the coin door where they could clear jams and maybe give a free credit if someone said they put a quarter in. But they didn't have access to that coin vault where all the money was going. And then when somebody would come in, typically an adult or the operator, they would open that coin vault, they would pull the coins, put them maybe in a special bag and label it what machine it came from, and then they could get the data from here as to how many quarters were expected there to make sure nobody was skimming or getting in there and taking some out. So there's a little secret button up inside that lower coin vault in the top that you press that'll bring up this screen on the monitor. And then this is where we go into the game adjust. So again, it's currently set to free play. If you look here, over on the right. And then difficulty of play is set, and then you can set the letters for high score. And then right here is where you would go ahead and do the clear bookkeeping, and you can reset the whole thing here. You can put in a track message on there if you like, Joel's Arcade, whatever you'd like, you can put on this screen, so it'll roll through. And then after that, it comes back to the a track mode screen here. It shows your high score. So the board's solid. I'm going to get it all the boards in some pink anti-static bags and packaged up with some bubble wrap, and coming back to again my customer Joel, and hopefully many years of reliable solid play. So thanks for watching the video, and we'll see you in the next one.